All right. Thanks lots for joining us today. Really appreciate it. Hopefully you're at the right spot. Today's webinar will be on EasyPower's new upcoming software module. We call it ECCM, and that's an acronym, of course, for Electrical Change Control Module. So it's what we call a technology preview here, where we'll be showing off this upcoming software tool, and hopefully you guys will find the content interesting. In the name of efficiency, we'll keep questions to the chat. So you should see in the webinar field here a little question section, and that'll be monitored by Kevin Bates today. He's our Director of Product Development, and so feel free to shoot him any questions throughout this presentation. And we'll also open up the floor for some discussion at the end of this presentation if we have time. All right. If you weren't here earlier, I introduced myself. My name is Minh Tran. I've been working for EasyPower for about 4 months now, and I'm their field engineer. So my job is to ensure the success of the customers, and so feel free to contact me if you ever run into any issues or have any questions. That's my job, to ensure your success. All right? So we're going to just jump right in here into this presentation covering ECCM, which is once again a new piece of software we're introducing shortly for EasyPower. So on the agenda today is, first we'll cover what is ECCM, why we created it, and what kind of need it fills within the industry. We'll jump into a demo of ECCM itself based on some kind of common application we recognize within the industry. And then we'll jump into some of the more specific features of ECCM. It's a search function and just overall change request workflow. And then we'll summarize everything. Hopefully that works for everybody. So we'll start off with a problem statement here that we recognized from our customers that we encountered over the past 30 years in the power systems business. And that is how to efficiently manage and control changes to electrical systems in large facilities where there's multiple personnel involved and they have different roles and responsibilities. So of course, take a step back here and explain that a bit. Is of course, some of you guys might be working in large facilities with lots of equipment and points of connections to the power grid and electrical system at that facility, and there's different roles within a company that have to be involved and interact with that system. Be that buyers and operators, electricians that are actually hooking up the equipment, engineers of all sorts, either in the manufacturing role, who are trying to get product out the door and produce whatever product your company makes, or the electrical engineers who are responsible for ensuring the facility meets power standards and safety standards, and then the technicians that might be using these tools on a daily basis. So how do we coordinate all these individual roles and synchronize these within a facility to ensure it's efficient, safe, and still produces the product your company is trying to produce? And so the current approach, when we came across customers, it's basically not sufficient from what we recognized. And so we introduced what we call ECCM. And essentially what this is an electrical system change management tool. So it's an integrated software replacement for spreadsheet-based engineering change requests. So in most facilities and companies that we've come across, the approach to change management within a facility involves spreadsheets and sharing them across email or on network drives. And so this is a relatively unmanaged approach, kind of prone to error and mistakes, and very inefficient in terms of utilization of time. And so with ECCM, we have a tool now which automatically synchronizes and updates the EasyPower OneLine as change requests are submitted, approved, and verified. There's also a smart search function, which I'll get into, where you can quickly search your facility, your power system, for appropriate points of connection for equipment as well. This is an efficiency tool which allows potentially non-electrical engineers to quickly find appropriate connection points. Of course, these will be verified and validated by electrical engineers in the process, but it's a good starting point and shows you what's available in your system. And finally, it supports multiple users at once. So this is a big change, and we're real excited about this, but we're the first power system software company that's going to be offering our one-lines and our ECCM software to be connected via an SQL database. And what that allows is that multiple users can be viewing one-lines and working on them at the same time, and also ECCM itself, of course, can support multiple users simultaneously, submitting change requests and viewing change requests. Okay. One thing I want to emphasize, of course, is this is a technology preview, so the software is not currently available for purchase or public release, and it's being piloted by a specific customer right now. But we do plan on releasing it in 2015, and we value your feedback and input in the meantime to make sure we got the product right. So now we'll jump into a practical application that we've run into, just one kind of common problem and approach to facility management. And that is in this case where, say in the manufacturing facility, we have to introduce a new tool, a new piece of large-scale equipment that's critical to the production process of a new product, right? And so the manufacturing engineer recognizes the need for this tool, and it's been purchased, and they have to install it. So, and the next phase of that would be that an electrical engineer has to perform an analysis on this new tool in terms of its load, and determine and validate any changes that this will affect within the facility, ensuring things like arc flash, short circuit coordination, and so forth are still within the standards. Finally, a buyer has to go through these list of tools and purchase this item. In this case, the final step will be an electrician will see that this purchase has been made, and then install the tool and verify that it's functioning. So historically, this approach has been done from our observation with this process here. So you can see here there's a manufacturing engineer, and then via a spreadsheet of some sort, he'll fill out a change request to add this piece of equipment, this unit cell with multiple loads and multiple power requirements. This will get passed on to an electrical engineer who then open up EasyPower and model this new tool, right? Verify that the power system, its effect on the power system will be acceptable and safe. At which point, the electrical engineer himself will fill out another change request or flesh it out a bit and pass that on to the buyer. In this case, the buyer, after getting approval from the manufacturing engineer and electrical engineer, will then purchase the item and fill out some sort of change request to get the electrician to install it. And then finally, the electrician closes the loop, verifies it's been installed according to the manufacturing engineer standards, and then passes it back. This whole time, this is done via the email or a network drive, and it's not very managed. You can imagine here a lot of these processes here can easily get tied up and mismanaged, or there's just kind of an open loop system here that just requires direct communication between various individuals, with potentially no visibility between each stage either. So the buyer might not know what stage the manufacturer engineer is at with regards to his needs for the tool and so forth. So there's a lot of documentation here, a lot of potential for data corruption in the process, and just largely unmanaged. And so I'll take a step back to the previous slide here. And so we recognize this need for a better way to do this and a better approach to change requests. And so you can see here the manufacturing engineer who might not need to access the one line can now use ECCM directly to file that change request. And they can also search for appropriate points of connections to put in this new tool, and not, again, have to inspect the one line carefully and verify any of that stuff. The electrical engineer themselves will receive a notification of this change request, and then also see that request within EasyPower, and we'll show that synchronization. And then they can then perform the analysis that they're an expert at within EasyPower to verify that, or validate, I should say, that these changes are acceptable and meet the standards and safety requirements of the company. And then they can do an approval within ECCM itself. and then the buyer will get notified to move forward with the purchase of this equipment, and then let the electrician know to implement the change. And both those steps can be done strictly within ECCM. So the value here is, of course, the one line of the facility, is very delicate. You don't want too many people opening and potentially changing that one line, because that's kind of, essentially, the core functionality of a facility. And so with ECCM, you can now effectively decouple people who only need to use small portions of that one line without accidentally affecting any change to the one line itself in a controlled and documented manner. And so some things we've observed in the past are, the way in which we've kind of marked up a one line for potential change requests, since they aren't synchronized, is, once a change request is filed, an electrical engineer or the manufacturing engineer will actually come into the one line itself and put in manual annotations on the one line. So these actually are just, notes that are put directly on the one line. They're not managed, they're not synchronized in any way, and they're not truly protected. So even though you might say not to connect any 480 volt tools to a certain panel, there's nothing intrinsic about the one line that's going to protect you against someone doing that. So again, this is relatively unmanaged. You got to make sure people are paying attention to these annotations, don't delete those annotations, and update those annotations as things change. And so there's a lot of risk for error there. And once again, you'll have people that might not need to be really accessing the one line and potentially introducing more error in the system and projects. And of course, there's no synchronization and control. So you might be filing change requests, and if someone doesn't make sure to apply those changes to the one line itself, then now you have a facility that's out of sync with the actual one line or with what the buyer and the manufacturing engineer are expecting. So this is just from our customers we've gotten feedback from. This leads to a lot of errors and takes up a lot of bandwidth in terms of worker effort to maintain this and control this. So with ECCM, what we introduced is a full-featured change request system. And so what you can see here, and we'll dive into it, demo is within ECCM, buyers, engineers, technicians can file change requests to add tools, change tools, or demo tools, essentially removing them from the system. There's full documentation, so depending on your company's format and needs for change requesting, you can print out these change requests and save them in any number of file formats. But along with that, when you file this change request and submit it and validate it, it'll also be stored in the database, the SQL database. That database is directly synchronized to EasyPower itself for the same one line. And so what you can see here is when someone like a buyer or a manufacturing engineer opens up ECCM and files a change request, it gets directly synchronized with EasyPower. So you notice the subtle distinction here is rather than have manual annotations that are floating around, what we have here are the actual tools in this case are highlighted, and then the actual change that's currently in process is indicated beside it. So what's nice about this is this directly follows the individual tool or piece of equipment within your one line, and if you hover over it, you can see a tooltip with the actual change request that it represents. But in the meantime, you can still perform your full analysis and short circuit analysis, coordination, and arc flash with these change requests pending and applied. So the one line functions as before for the electrical engineer, except they are aware of any change requests that are currently out there. But it didn't require any extra effort in terms of applying those change requests based on the manufacturing engineer, technician, or buyer making those change requests. These are already directly applied to the one line over the database, and so there's no risk of any sort of non-synchronization and minimizing the labor required to make sure that the change requests match up with the current one line. And we'll jump into an example here really shortly now, but hopefully you guys can see the benefit of this already. One thing I'll mention just briefly here is you might notice, if you guys are familiar with EasyPower, and hopefully you are, is that there's a little triangle symbol here that we have currently highlighted for the change request. This is a new item that we're going to be adding to EasyPower shortly, and it's called a tool. Essentially, it's a grouping, a tool point of connection, I should say. So this triangle represents a point of connection onto the power system for the tool that we mentioned here, which is essentially a grouped bus of multiple loads. And so it represents kind of a large piece of equipment at a facility which might need different points of connection for power and represent different loads. And so each one of these triangles represents a point of connection for that tool. And it's essentially just a bus and a load. So we're excited to introduce that, and that's where, in this case, the change requests have been applied to. All right. So again, just to emphasize that synchronized nature of this is we have two software tools here that are distinct but share the same database, and that's EasyPower, which you're familiar with. That's our power system analysis tool for the purposes of modeling, analyzing, generating reports and labels, and so forth. And then we have ECCM, and this is a tool for filing change requests, searching for appropriate points of connections, and generating the change request documentation necessary. They share the same database, so they're synchronized, essentially. And of course, the previous approach to do this would require just emailing back and forth the change request, applying those changes to the one line, and then verifying those one lines manually, sending out other emails, sharing files on a network drive that can be copied over and easily deleted or changed, and without any documentation for any of that. So with ECCM, of course, we have a complete log of any changes, any requests, any sort of rejections and verifications of the change requests as well. So we have a complete history of any change requests that allow us to easily track and manage those. So now I'll jump into an ECCM demo. Essentially here, before I jump into it, you can see here the ribbon. So we've modeled this after our EasyPower ribbon, so you can quickly get familiarized with the environment quite easily. And so we feel it's a pretty intuitive interface that allows users to jump in and get going quite quickly. Okay, so I'll open it up right now. First off, I'll open up something you guys are familiar with, which is EasyPower itself. So you can see here, we have the one line we're working with in our facility. Okay, hopefully everyone sees that. It's a pretty large one. And already, if we zoom into certain portions here, you can see something that you probably haven't seen before in EasyPower, which is, as I mentioned, those change requests. These are some ones that have already occurred. And you can see the distinction here. The addition, the plus sign, of course, means we're adding, in this case, a point of connection for a tool into our facility. The yellow arrow, sideways arrow, indicates a change to something about that point of connection. And in this case, a negative minus sign, subtraction sign, I should say, indicates a demolishing. So a demo, a removal of a point of connection on the system. You might notice here when I hover over these change requests, we can pull up some details about that change request. In this case, its number and when it was submitted. So you then can quickly correlate within ECCM what these change requests are specifically, who filed them, when they were filed, and so forth. So I'll close this up here. Save. And I'll open up ECCM. All right, so when we first open up ECCM, what you can see here is, as I mentioned, our ribbon with all the functionality here. And then in this case, our dashboard, which shows the different change requests that have been filed. And there's several filters here, of course. You can filter out to show different change requests based on what you're interested in. And this is really useful as the user, right? For example, if you're a manufacturing engineer, you might only care about pre-assignments and whether or not yours have been approved. If you're the electrician that's going to be installing this, you want to check the verified list, right? You want to see which change requests have been verified, because those are the ones that you have to now install into your facility. If you're the manufacturing engineer, you might want to check the rejected list, again, to see if any of the change requests you requested have been rejected by the electrical engineer. So again, quickly you can filter out these to any ones that are relevant to your needs. Of course, you can filter by user as well, so you can quickly look and see which users have applied any changes that are relevant to you. In this case, you can see that. All right. Along with this view, which we call the dashboard view of all the change requests, you can pull up a one line. So this is the exact same one line that we just pulled up in EasyPower, and this is kind of a viewer mode where we can quickly view the one line itself as well. Of course, it's read-only, and that's another benefit, as we mentioned, is so now people that shouldn't be modifying the one line don't have the ability to, but they can still view it, which might be valuable, right? So once again, a manufacturing engineer might want to view the one line to understand, where the connections are available in a system and just things like that. But they won't have the ability to accidentally modify something. That'll be left to the electrical engineer, who can open up EasyPower and access that capability. The one thing you can do in the one line is you can still bring up your change requests. So let me just find out where those change requests were previously. So in this case, we have a change request for a breaker. So within ECCM, you can pull up change requests by hovering over them and double-clicking on them. So apologies, that was a pre-assignment. I'll find a change request here. I thought they were all over here. I will find one, I promise you guys. Where'd they all go? All right, well, hopefully you guys can trust me that we can, in fact, open up change requests directly from the one line to view them as well. And of course, you can open them up as well directly within the dashboard view. And I'll show you that right now. So you just hover over anyone you wish, double-click, and bring up the change request. In this case, I'll take a step back. And so one of the most powerful features of ECCM is our search functionality. So I'll show that right now in the role of a manufacturing engineer. Okay. So you can imagine you can click on this Add and Search Tools. And as a manufacturing engineer, say we need to add a new tool to the facility. What we can do here is name that new tool. So I'll call mine, and keep with the convention we maintained here, I'll call mine T-Min and give it another further ID and add it. Okay. So now we have to add these points of connections to our facility for this tool. So what we do here is click Add Point of Connection for this new tool and specify the requirements necessary. Okay. So in this case, the type of power supply, choose a normal power supply. We can name that point of connection. In this case, we'll call it just EO1, electrical 1. The base KV, in this case, some sort of tripping current. The full load current. Number of poles. Yep. And then say, in this case, the location. And we'll find a location here. And the floor, in this case, manufacturing. So these, of course, will be specific to your facility, and they'll be customizable based on how your facility likes to arrange and enumerate their locations within the facility. The value of this is, based on this information, we can determine cable lengths, and our search can be dictated by the length of the cables to minimize those if you wish. Okay. I'll add another point of connection here, in this case for critical power supply or emergency. This case, this will be something lower, so you can imagine, again, tools have multiple points of connection. So here we'll do 30, 15. Yeah, okay. Base KV 208. Same location, same floor. And so with all this information, we'll perform a search. And the search will be prioritized by these things here, which again probably change and get modified as we release the product. These are largely specific to our customer currently. But we'll click Search. And now on this one line that we already shown you, we'll search through the entire facility, the entire power system, for all of the points of connections or all the breakers which will meet the requirements of our points of connection for this tool. So you can imagine this would have been a very laborious process previously for a manufacturing engineer or any other person with the need to add a tool to search through and be aware of the one line and the necessary loads and so forth and to find it. But here with the search tool, we've just traversed through the facility one line and found any appropriate connection. And we've sorted them, and we can control and filter how we sort these points of connections. But in this case, we found this first one here, which looks appropriate, in which we have 2 points of connection in the northeast for a bus and a panel, which meet our needs. So what we can do here is then directly create a change request from this search. So you can create a change request on its own, but you can also now, via the search, directly create a change request based on whichever point of connection you choose to make. And again, you might recall I chose the floor and location in the facility. That'll determine the calculation for the distance based on our tool and then the appropriate points of connections. So you can organize and sort according to that. Right now I'm going to create this change request. And you can view here the change request window that we showed previously. Right? So at this point you have several options. In this case we chose to add a tool. So in this case you can see we're adding these points of connections here with these names with these following panel locations. Up here of course you can change the point of connection. So you can always just create a change request from scratch and choose to change a connection or demolish one, just as we mentioned before. Here there are a couple things we have to fill out for these connection points. So you can choose the poles here, breaker types, and then conductors. So in this case we'll just fill this out. And what this allows us to do is model this device. We'll pass this information on to EasyPower, and so we can model these new additions immediately, directly out of the gate. Some of these things aren't required, and some of these are. So you can see that here is up top we have a validation button. So you can always, I'll click on this and show you right now. What we can do is, while we're filling out this change request, we can check and validate that we've filled out the appropriate settings that are required. Of course, if you click submit, we'll also be doing that same validation, right? In this case, what it's telling me is I have some breakers here and I haven't specified the settings in which I'd like to attach it. So here we just put in some pickup delay, short time pickup delay, instantaneous, and so forth. All right? Now we can click validate it again, and we've passed that validation. At this point, we can submit. Click submit right here. And besides warnings, there's also full-on errors. And so if we specify an error, in this case something real simple, like say we name both these connections the same and click validate, it'll throw a full error. In this case, specifying that 2 points of connections we requested have the exact same name, and so we won't be able to submit them until we change this. So there's fairly extensive error checking going on here, and it's a feature we'll be able to customize based on, the users will be able to customize based on the requirements of their facility. In this case, we'll click submit now. We should be good to go, and submit it. All right. So now if we want to take a look at these change requests that we applied, we can close this. And in the dashboard view, you can sort by right now and find the one I just submitted. Right. So it was submitted by me, and it's Minh Tran here. So if we sort that out, we can quickly see this change request. If you want to see this change request in this dashboard view, you can double-click and bring it up. You can quickly see this. Make any further changes, add another change request to this, submit it again, and so forth. In this case, I have complete permissions enabled, so I can actually approve this change request or reject it as well. Of course, this would typically be done by the electrical engineer or someone else, the manager perhaps, who would go in, look at this change request, and approve and reject it accordingly. Perhaps after opening it in EasyPower first. And I'll show you that shortly. But first, I want to jump into the one-line view here and show that these change requests were applied. So you can hover over here and see now I've added this point of connection. You can see the plus sign, in this case, to panel D and for NEC. And as I was trying to show you before, if you want to hover over this and double-click on this, it'll actually bring up the change request. So in ECCM, when you view the one line, you can double-click on the change requests that are highlighted and bring up the change request. But you can't double-click on the bus, for example, or the transformer and modify any of those values or change any connections. So again, you get that visibility and understanding of your system, but you don't have any opportunity to potentially change the system. So we have that scope there. And here is that second change request I made, and you can double-click on that. Of course, see in this case, this is the change request to be filed for this point of connection. In this case, within a panel. All right. Now what I can do is we can open up EasyPower again. In this case, I'm going to point to our SQL database here. So this is a little new. So our SQL server with the database and the individual one line, we call it a project within that database, and open it up. So this is the exact same one line we were just looking at in ECCM. We had it open earlier. But now, if you zoom in, you can see that change request that we just filed. If I hover over it, I can see that the code for that change request and the state that it's in this case, submitted. Right? That can also switch over to validated or verified and so forth. But in this case, if I click on this, since I'm in EasyPower itself, I can actually modify, the values here. And a lot of these were transferred over, of course, into EasyPower from ECCM. In this case, all the conductor information we were filling out and the breaker information. What's nice about this, though, is now, as the electrical engineer and person responsible for maintaining the facility and the power, you can see when you open up the one line, this change request, go in and now validate that electrically this is acceptable. In this case, we'll switch to short circuit mode, arc flash, and fault this. And quickly, we get the arc flash calculation for this new tool. And then we can verify, generate new labels as necessary, verify this is acceptable within the system, perform coordination, so forth, and ensure that this is what we want in the system. There's no potential issues. And same, of course, goes for the panel we just applied a change to. You can pull up the panel just as before and do the arc flash. Pretty exciting stuff, right? To be able to synchronize and cleanly share information between members of your team like this. And then as an electrical engineer, after I verify that this is acceptable in terms of arc flash, short circuit, and power flow, I could go in to the ECCM now and open it up as the electrical engineer and approve these changes. So I can go here now, after I've performed that arc flash calculation, double-click on this, change request. You'll notice something new as well. When I brought up this change request, EasyPower has passed along those arc flash calculations and put them in the change request itself. So now, the electrical engineer, once they perform these calculations, now the manufacturing engineer can see these as well, these results. The buyer, the manager can also see that the results have been performed and make sure they're acceptable. And then whoever has that role can now approve these changes. So in this case, I will approve of this change request as the manager or as the electrical engineer after I performed, in this case, the arc flash calculations. Click Approve. So we've approved of these changes. Okay. Now, of course, if you go back to the request by status, so I was only looking for submitted change requests, that entry is now gone. But if I go to approved requests, I can see that you can view that this change request I just made to my tool has been approved. If I pull it up, again, you can see the status of it. So you have a complete history and log of even approved requests. So in this case, Joseph Jones, pull him up and look at some verified You can see we have a complete log, a traceable log with dates and times of any change request. Pretty exciting stuff, right? Now, if we go back to the one line, of course, in this case, you can pull up these change requests and see that in this case, they're still approved. But if we want to now, as a role of the electrician, we've seen this list of approved tools and we want to install them in our facility, we can install them. And after we install them, our role is then to verify and let everyone else in the team know that we've successfully installed the tool. Previously, that would require, again, filing another change request, emailing it out, or putting it on a network drive and hoping people read it, and so forth. In this case, as the electrician, once we install a tool and verified its connections, we can click Verify. In this case, because we have access to ECCM. So again, we don't have to go into the one line in EasyPower and potentially mess it up or put some manual annotation saying verified. In controlled fashion, ECCM, we go in, click Verify, and verify the change. Okay? If we jump back to request by status here, you can see if we pull up only verified changes, we have, in this case, two change requests that are verified. Then we go back to the one line. And one thing you might notice here now is that on the one line now, there is no longer a change request highlighting this one line, this element. So at this point, the change has been done, right? We requested the change, we validated the change was acceptable, and now we verified the change was implemented. And now we don't want to see it. We don't want it cluttering up our one line anymore because it's done. You know, now it's officially part of the facility. You know, and so in EasyPower, let me open up this library again. So we open up this project now in EasyPower as an electrical engineer, maintaining the power system. Those changes have already been applied, and so now this is just part of our one line. So we keep our one line uncluttered, but directly synchronized to any changes that are happening. It's a very dynamic way of keeping track of things and a very efficient way of implementing changes within your facility. Okay. Just going to jump quickly back into the presentation here. Hopefully you guys understood the value of that demonstration. So as an overview of the search engine, you know, it's capable of searching and locating buses, panels, and breakers to which tools can be connected based on the electrical parameters you fill out. You know, tripping amps, full load amps, poles, and so forth. And so this allows non-electrical engineers and non-experts in the power system to quickly find and you know, suggest points of connection based on design criteria. And then you create change requests directly from that search, and those get passed on to the person responsible for the power system, and they can validate the changes, verify those changes, and perform necessary analysis. At that point, they can verify it and pass it on to you know, the buyer or whoever else is next in that chain. All right. Here's the search workflow. It's probably a little more specific than we need to get into today. This is relatively applied to our one customer currently that is piloting this project. You can see, again, you search for a tool. If it's a new tool, then you can create that tool's parameters and then search for an appropriate connection. If you find an appropriate connection, you create a request. If that tool already exists, then you can just specify if you want to add connections or change connections and perform the same kind of change, perform the same kind of search, and then create a change request. But all the while, this is you know, this is being performed on not the actual one-line file. This is performed in ECCM, looking at the one line, but you can't accidentally modify anything and make any changes. And then when you file the request, that is applied to the one line benignly. So you just visually see that a change request is applied, but it doesn't affect the circuit yet necessarily. That's up to the electrical engineer to test and verify. Okay. And so here are just some factors here. I won't go too deep into this, but in terms of the things we can search for and verify regarding connection points for tools. So type of power, type of panel, and then the facility itself, and then of course voltage, current, and distances. Available space, if there's spare breakers, so forth. And these can probably be tuned based on your facility's needs and your company's needs. These are just some common search tools, search parameters we've implemented currently. And here's just the overall change request workflow that we've chosen to implement for ECCM. So you can see here you can create that change request, of course, and submit it. At that stage, you can either be approved or rejected, of course. This could be done by the electrical engineer perhaps, or a manager. Of course, it was created by a manufacturing engineer. If it's approved, then we can verify it via an electrician, and then it's verified, and it's no longer annotated on the one line. In another stage, it can be canceled at any time, of course, and canceled. So that'll remove that annotation from the one line, or it can be rejected and resubmitted, of course. We have another thing here called layout release. I won't get into it too much, but that's a way in which you can, in mass, outline several potential changes you have planned for your one line, but not formally implement them on the one line itself. So they won't affect any calculations yet, but you're effectively reserving points of connection for some sort of future layout release, so that viewers of the one line and viewers in ECCM can be aware of some sort of changes that are planned, but they won't be modifying the one line calculations just yet. Okay. So as a summary, ECCM is a standalone companion product to EasyPower, and its main purpose is to manage change requests in a facility. It can be used by both electrical engineers and non-technical personnel that are responsible for changes and additions in a facility. What's nice is it's self-documenting and synchronizes these change requests with EasyPower. So change requests can be filed, and you don't have to then perform those same changes in EasyPower and hope they're synchronized and manually document them and annotate them on the one line. This is all managed directly between EasyPower and ECCM. Changes in EasyPower are reflected in ECCM and vice versa. We support multiple users. So this is running on a database now via servers. And so you can have multiple people open up ECCM and be filing change requests on the same one line and same facility at the same time. Similarly, you can have several people opening up EasyPower at once as well and taking a look at it. Target applications are large industrial facilities that have a lot of changes and high turnover in their equipment, and with multiple people and personnel involved in these equipment changes with different roles. You can imagine, we've had a lot of customers come up to us, and they've expressed frustration and challenges in maintaining this change request system via, spreadsheets and emails, and so we thought it was an appropriate time to introduce a tool like this. So if you have any follow-up questions you think of, would like, a one-on-one webinar demo with your company, or have any specific feedback on features that would be really valuable to your facility and your company, feel free to shoot me an email at min@easypower.com. But at this time, this concludes the webinar on ECCM, the Electrical Change Control Module. Hopefully you guys found that valuable, and talk to you guys soon. Take care. Thanks.